Hello, everyone. This is Mr. Kleinhans, and this is the Introduction to Earth Science. So, what is Earth Science? Earth Science is the study of Earth and the universe around it. It uses observations and experimentation to discover the causes of natural events. Cultural contributions. China kept records of earthquakes dating back to 780 BC. The ancient Greeks cataloged rocks and minerals. The Mayans tracked celestial movements in the nighttime sky. There are four major areas of study in earth science: geology, oceanography, meteorology, and astronomy. The first one, geology, is the study of the origin, history, processes, and the structure of the solid earth. Examples include a volcanologist who studies volcanoes. Oceanography is the study of the ocean. Example, studying waves, tides, or ocean currents and how they may affect climate and marine life. Meteorology, the study of the Earth's atmosphere, especially weather and climate. Examples include a meteorologist who uses Doppler radar to track storms. You have a picture of a tornado in the top right and a picture of a lightning storm. Astronomy. Astronomy is the study of the universe beyond the Earth, the oldest branch of Earth science. Example would be space exploration. Environmental science. We don't study too much of this in earth science. You may go on to marine biology and oceanography next year, and you'll go into more detail with environmental science. It's the study of the way humans interact with their environment. Example would be of pollution, biodiversity, and the use of our natural resources like coal, oil, diamonds, gold. So why is earth science important? Well, it's important because it is an understanding of the natural forces that can help predict potential disaster. And we also need to understand conservation of our natural resources for the future. So science as a process. The behavior of a natural system. The scientists assume that nature is understandable, similar forces equal similar results, and nature can be predictable. The ice cores provide clues to the Earth's past and climate changes. The ice cores are sliced thin, and the gases they contain are analyzed, so they can determine what type of gases were in the atmosphere dating back thousands of years ago. Scientific measurements and analysis. Measurement is the comparison of some aspect of an object or event with a standard unit. The international system of units is used worldwide and based on powers of 10. That would be like the metric system. Accuracy and precision. Accuracy, how close a measurement is to the true value of the thing being measured. Precision is the exactness of the measurement. So, picture A shows a precise but not accurate. B is accurate but not precise. Picture C shows one dot in the center of the bullseye, which is precise and accurate. There is error involved. Error is an expression of the amount of imprecision or variation in a set of measurements. It's expressed as a percentage error or as a confidence interval. Observations and models. A model is a representation, description, or imitation of an object, system, process, or concept. The conceptual model, verbal or graphical, it represents how a system works. And then we have mathematical model involving the equations. There are only a few equations in earth science that you need to use. Most of them will be conceptual models, which is a graphical or a image representing how a system works, such as a volcano or a waterfall or a river. Scientific publication. Scientific results are often published in journals, and they're written in a standard scientific format. Many journal articles are found online, through these different websites, which we'll be using throughout the year. Peer review. This is when articles are submitted before they're published. Several experts will read through the article and make sure it's worthy of publication. Scientists follow a code of ethics that only scientific results should be published. Formulating a theory. A theory is an explanation that has been tested and supported by experimental results. Theories are based on scientific laws. Scientific laws are general statements that describe how the natural world works. An example would be the law of gravity. You have a picture of Isaac Newton with an apple falling on his head, and then a picture of the Earth and the Moon orbiting the Earth due to their gravitational attraction. Interdisciplinary science. The exchange of ideas between fields of science supports scientific evidence. When an explanation is supported in a variety of fields, it's more accurate. An example would be the meteor impact hypothesis, which states that 65 million years ago, a large meteor hit the Earth, and that caused the extinction of the dinosaurs. Science and society. Advances in science have led to the development of new machines, tools, materials, and processes. Technology that was designed for space exploration has been used to improve computers, cars, medical equipment, and airplanes. There are problems with technology. New technology can lead to new pollution. The risk, the cost, and the benefit must also be considered. For example, drilling for oil in Anwar will cause irreversible damage to the tundra. Scientific advancements. The main goal of technology is to solve our human problems and make life better and easier for everyone.